Good day to fellow classmate and Dr. Moraslina. I'm here representing Group C on analyzing the data which is given to us on the production of Lajak Kuruih C tablet on the month of December 2020. I'm Cyrus Lee representing my group to further discuss on the data that we have collected. In this presentation, data of the pill Lajak Kuruih C tablet has been gathered to further analyze on whether the product produces is quality controlled accordingly to the standard of the Food and Drug Administration Authority requirement. The 200 sets of data were collected based on the weight, hardness, and mixture density. As mass production may encounter these three criteria, and random data collection needed from time to time to maintain the production quality, and improvement needed once the variations of the product diverted from the approved standard. The data were collected based on 3 shifts: morning, evening, and night. Based on the data collected, we can separate it into 3 different criteria for monitoring and justification. We will be using the sample collected and separately analyze them using the method of descriptive and inferential statistics. From the data collected, we are able to get the mean, median, and mode of each categories to further analyze it using various of tests and methods that we learned from statistics as to further enhance the quality of the product productions. By using Excel, we can direct convert the data collected to simulate a graph to show the frequency of the relative density, which is shown in this graph, and furthermore, we also able to use the data to see the frequency of the tensile strength from the data by using Excel as shown in the graph. As frequency of the weight also can be done through Excel, and it is shown in the graph above. For these 3 graphs and the data we collected, we are able to know the frequency of these 3 criteria, and so as from this data, we also can use the Excel to enable us to get the means and the median of these 3 criteria. By using Excel pivot chart, we are able to summarize the data, the 200 sets of data, into this chart, which shows us the average of each criteria from 3 different shifts and standard deviations of these 3 criteria from different shifts too. From this data gathered, we can further apply the methods or tests we are going to use to further analyze the data we gathered. So, from the data collected, we decided to run 3 tests on the data. which to justify our decisions whether we accept or decline the batch of this product. The first test we are going to use is a goodness of fit test, which the hypothesis will decide or whether we can accept the tablets or reject this batch of tablets. Then supported by the second test is which is ANOVA. ANOVA will be using the variance of the three criteria include weight, relative density, and tensile strength to further justify the hypothesis or to support the hypothesis on the previous test. And lastly is a linear regression test, which we further look into the relative density versus the tensile strength, and to support the hypothesis for the previous two tests whether it is acceptable or unacceptable for the batch of this product. Further detail will be explained in the link attached in this slide. Please click on the slide for further explanations. Thank you. From the data collected, we decided to run 3 tests on the data, which to justify our decisions whether we accept or decline the batch of this product. The first test we are going to use is a goodness of fit test, which the hypothesis will decide or whether we can accept the tablets or reject this batch of tablets. Then supported by the second test is which is ANOVA. ANOVA will be using the variance of the three criteria include weight, relative density, and tensile strength to further justify the hypothesis or to support the hypothesis on the previous test. And lastly is a linear regression test, which we further look into the relative density versus the tensile strength, and to support the hypothesis for the previous two tests whether it is acceptable or unacceptable for the batch of this product. Further detail will be explained in the link attached in this slide. Please click on the slide for further explanations. Thank you. I'm Cyrus Lee representing Group C. I will be discussing on question D, how we are going to solve the question D. As question D, we will be using linear regressions, simple linear regressions module. We acquire the R square. R square is a portion of the variance in the response data explained by the regression model, which we get the value of 0.741420 8042 of the original uncertainty in the value of tensile strength by the regression model, and is acceptable as shown in the formula here below. Y is equals to alpha plus beta x. And the validity of the tensile strength Y is corresponding to this relative density on x-axis. This is x-axis and this is y-axis. All these are data that we collected from previous tests we run from the ANOVA, which is using the variant of the data. We only selected these two data for further justification and conclusions on hypothesis before this. And the alpha, we managed to get the negative 0.5095 from the data, and the beta is 0.0869. The hypothesis beta equals to 0. The relative density is non-linear relationship, and the hypothesis that we are going to test is beta not equals to 0. The relative density is a linear relationship. Okay, reject hypothesis no if t test more or t alpha divided by 2 more than this. Reject H null if t test is more than 0.025 199. So alpha, we are going to use alpha equals to 0.05 as given. Okay. From the data getter, it shows that the low relative density is 68%, x 74.3%, 80.1%. And as for the assignment shows, stated that table's hardness can be represented by its relative density and tensile strength. Study indicated the strength depends on the relative density regardless of production shifts. Recently, a batch was found to produce, as we gather from the data, is the similar answer that we get. And what is the prediction of the tensile strength for such tablets? Comment on the validity of the product that you have used to carry out these predictions. Based on the data and the result we calculated, the conclusion of the prediction is invalid because x, the low relative density, is not in range in the data we calculated that we get. The minimum and maximum value is 82.8 from our calculation and 93.9 that we have calculated from the set of data we collected. So we are not able to accept this batch of product as it is not in the range of acceptable medium. So this is our explanation, and thank you.